Greetings, Earthlings. What you see here is a Fluke 343A voltage calibrator, which goes up to 1,000 volts and has a basic accuracy of, I believe, 0.002%. These things date back to the 1970s. And so you can see this one has sort of seen better days. It was sold to me as a parts unit, and I thought we'd try and get it working here. You can see this is bent in a little bit here. The seller showed these in the photos when he was selling it, so there was no attempt to deceive. It was, but he also said he had plugged it in, and it powers on, and the knobs appear to work, whatever that means. And I guess, so there's no sparks, no smoke coming out, and should basically be safe to plug it in. So the other thing is, you saw that bashed in. This dial is broken here, and there's a missing shorting bar there, which should go between the green and the black. Turning it around here. Oops. Again, this was shown. Little denting there. What wasn't shown, so may have happened in transit, is, let's look over here. Right about there. You see that? You see how that's bent and cracked? That wasn't shown in the photos that he supplied. So it looks like it may have been dropped again in transit, as I said. But again, looking back now, there are 6 screws on the top cover. 2 of them still have stickers on them, so this thing has not been opened since it was last calibrated, which is a good sign. Oh, I guess the other thing is there is something rattling around inside there, which we'll find out. But see, no one has messed with the calibration. Well, the other thing I see here is that this dial is sticking out a bit, as is this one. These others are pretty much flush up against the front of the panel, and there's a gap on these, which I don't understand. This one wiggles a little bit, and I can see the bushing in there that really ought to be back. But again, those look like they'll come off, and I can readjust that. And what I can do on the broken dial is move it down to the last digit, because this is 7.5 digits, which means that the highest order digit goes to 10. But let's plug it in and see what happens. Okay, plugged it in, and put it to standby there, which did not appear to do anything. No lights came on or anything. Okay. Well, that's a sign. Okay, we got a light there and a clunk from a relay. There's a light came on, which says on. I'm going to hook it up to the voltmeter. Now this is my Tektronix DMM 4020, which has been recently calibrated. It's only 5.5 digits. Okay, I'm on the 10 volt scale, so let's give it 1 volt. 0.999989, and I've just turned it on, so it hasn't had a chance to warm up and stabilize. Did the meter do anything? Yeah, it moved a little bit. Okay, that's a positive sign. That's pretty close to 1 volt. 2 volts. 2.0, okay. Within one count there. Crank it up to 10 volts. What the heck? 9.9999. That's pretty good. See, that would be 10. Okay. That would be within spec on this anyway, because if you read the specs, this is like 0.15% accuracy. 0.15, 0.015, 0.015, I think, percent accuracy, and then plus or minus like a digit or two in the last digit. From the calibration, which was done a few months ago, July. It's now December. 19 volts. At 19 volts, I'd have to go to the 100 volt scale and go to 19. Okay, that's 19. And the readout on that was somewhere here. Got 19.0006. Where is it? There. Oh, way over here. Okay. 19 volts, 19.0006. Anything between 18.9963 and 19.0037 is in spec for this meter. Well, I've got 19. 18.999. Pretty darn close. And that's just out of the box. So this is looking good. Let's go to 190. If I crank it up a decade. Oh, wait. So there are lights here, which are like decimal points. So I'm on the 10 volt scale. That should be lit. That's burned out. Okay. That one's working. Go to the 1000 volt scale. That light should come on. It's burned out. Okay. So it needs a few things done, but okay. This is 190 volts. And when it was calibrated, it read 190.001 on their equipment, but anything between 189.966 and 190.034 is considered in spec for this meter, and so this one is showing pretty much in spec. They measured at 1,000. I've got 1,000.03 without everything warming up. He got 1,000.01, but 998.82 to 1,000.18 is in spec. So yeah, this is actually looking like a little better than a parts unit. But again, a few lights burned out, switch, a couple of switch things. The other thing is inside. Well, like I said, something's rattling around in there. And the capacitors on this, electrolytic capacitors, because of the age of the thing, tend to be on their last legs. So let's put it down to a less lethal voltage. It's not voltage, it's current that kills you. Okay. Oh, and it's got current limiting too. I don't know, I haven't played with that. Well, I'm on 0, but if I go back, let's say go back to 10 volts. 10 volts. And there's basically no load on it because this thing has a, but it did, the current limit did kick in and the light didn't come on. So that seems odd because, this has a like 10 megohm or more input impedance. And so all the way down it should be 1 milliamp, but it's in current limit there. And then fully up is 25 milliamps. So maybe some issues there. And again, I think that's indicative from what I've seen online about this. There's not a whole lot online about these. But I think from what I've seen, that's indicative of leaking capacitors, electrolytics. So it will not be a bad thing to go through and check all those capacitors, potentially just replace them all, given their age. This thing is, I don't know when it was made, but again, it dates to the 70s, so it could be pushing 50 years. I'd say it's at least 40 years old. I don't think it's any newer than 1980. Okay, I had to replace the battery in my microphone, but we'll open this thing up now. What I'm going to do is, there's a bottom panel as well, so let's turn it over and do the bottom side first. Did you hear that? You hear that? Something rattling around in there. Okay, oops. Here's the other thing that's missing is the like feet that it would sit on. Okay. And somehow this panel lifts off. I said, yeah, okay. Okay. So there's that ding. I can straighten that out. You can see that? Where is it? Where is that? Where is that? Yeah. Little ding there in that panel. Okay. But looking at it now, it looks pretty good. This is Rev H. I don't know what that means. It's a conformal coating on the board here, which is good, and no indication of any previous repairs, which would probably be visible because you'd have to burn through the conformal coating to replace parts or anything. So it looks like it's had a fairly good life, aside from being dropped a couple of times. Okay, there's a panel here. Oh, hear that? Hear that? I heard that. Let's look inside here. And yes, it's unplugged, okay? It's unplugged. There's the plug, there's the plug, there's the plug, there's the plug. So 2 screws here. We'll see what's under this panel. Get this cover. Well, it's the switches. Aha! There's the rattler right there. And where did that come from? I'm not seeing because again, all the switches work. I'm not seeing, I mean, I'm assuming that came off a switch. Either that or it's just a spacer. No, it's a switch extension of some sort, it looks like. But I don't see offhand where it's from. Okay. Put this cover back on. And we'll flip it over and we'll avoid the calibration. Okay. Flip it back. Upright. Oh no. There's something still rattling in there. Maybe it's the pieces that have broken off of this. This has another half to it. And that has another half to it. And now, for the first time in I don't know how many years, there's a ding here, which again I can flatten out. There's a ding over here. Just some automotive auto body flatteners. Should be fine for that. Okay, this is a cover. I see parts. Ooh, there's neon bulbs in there. There's that relay that makes that big clunky noise. Interesting. Cover there. There we go. A bit of a close-up shot of the board. You can see all these axial lead capacitors, which are the things that tend to flake out, as I understand it. There's a couple of it's all the blue ones. Well, there's some silver ones too. Basically, they should be replaced. Let's see if I can see some date codes on here. 79 on a resistor here. So this might date to 1980. Late 79 date codes. So it might only be 40 years old. Let's look under this cover. This is the top view of what we saw before. Aha! I see the rattler. It's over here. And again, it does look like another piece of the same one I found. That looks like that came from there. Yeah. Okay, and that, that looks like it went on a shaft. Oops, where is it? Where is it? Where is it? That looks like that went on a shaft. And this went on another shaft or something. So here, and there look like similar bits, but they're all intact. So I'm not sure where this is from. I'm going to make a guess here, and this is totally a guess. The underside had no, calibration stickers on it. So my guess is that it was dropped, which broke this for one of these switches, and somebody went from the underside and replaced it, fixed the switch, but didn't find the pieces. Or maybe they found one piece because there are two here and it looks like there should be three. So I think the repair job was done from underneath, didn't affect the calibration. They said, hey, it's good to go. So remember, this one and this one are sticking out a bit. And I found the broken plastic pieces in there, and I said it looked like, maybe someone had made a repair at some point. I'm thinking, from what I see here, yeah, they just have these metal sleeves, collars, whatever. So it comes out the shaft, and then there's a shaft coupling, and then that goes to a nylon shaft. I'm wondering if those are the repairs. This thing was dropped. Those things needed replacement or something. And so they were replaced, and that's why they are different than all the others. But I don't know, because I don't have another one that hasn't been dropped to compare it to. I am now going to test the capacitors. I won't do that on camera unless I find something interesting, but this is what I'm going to use. Okay, and it's got these leads. So this will let me measure capacitance and ESR and see what looks good, what looks bad. Okay, well, I've checked out the capacitors, and I took the cover off, of course. And most of the capacitors check out pretty good. There's a few that seem a little iffy that I may replace. But there's a couple of much more interesting things going on here. I don't know if you can see this very well, and maybe I can zoom in. But there's a jumper right there, and that has been cut. And it's been cut intentionally. I can see the mark on the PC board that the knife made or whatever to cut it. So I don't know what's up with that. Over here is another jumper, and one end of it is sticking up in the air. That one looks like it broke off. So I have to figure out what that's all about. Okay, and further investigation on these jumpers show that they do appear to be there for calibration purposes, and you cut them if you don't need them, because they're shown on the schematics. Here's one. This is the big one. It's across R163, which is this one right here. Okay, that's R163, and on the schematic it shows a jumper across there, and it's an optional jumper because it's a dashed line, obviously, because otherwise why would you bother to put a resistor there? The other ones, the two little ones, which were down here, they're also shown on the schematics, if I can find it. And they're right here. So this is in the calibration for the 15-volt reference supply. You've got the adjustment here. There's a resistor in parallel, and then there's two other resistors optionally in parallel. And so I checked the voltage on that 15-volt reference supply, and it is spot on. So I am not going to mess with those jumpers. Okay, I've got some replacement bulbs here. I'm just going to go in. There's 5 bulbs, I think. 1, 2, 3, 4. Another one somewhere. 5. Just going to replace all of them. Bought 10. Oh, great. And they came loose in the bag. Now, some people will replace these with LEDs. I'm not going to bother with that. Just go with the original style bulbs. I don't see any reason to change it to LEDs. Although I'll say the limit, there's supposed to be a red lens there. That's supposed to shine red, and it's not. It's amber, just like the others, which is just the natural color of the bulb. But I'm not going to worry about that either. They have these little boots. I guess it's like silicone that they fit into. It's just a friction fit to hold them in place. One of the boots, well, it's the one for the limit bulb, was torn, and that's why earlier when we looked at the lamps, that one, we didn't see it lighting. It actually was, but it was loose inside here. This one is giving me grief. So I just taped the boot with some vinyl electrical tape. Just to hold the boot together. Doesn't touch the bulb, so I should still be able to take the bulb out. But it'll hold it securely. So one at a time. Yeah, I'm going to leave that one for now. Since I believe it was working, let's plug it back in and see what we got. Standby. Oh, good. Range. There's a, see, that's a little orange, but it should be red. 10-volt scale. 100-volt scale. Woohoo. 1000-volt scale. Excellent. If I turn it on, That light comes on. And yeah, we're good. Okay. Well, that is way better than it was. And let's look at this one. Same deal. So. Better. And now, regarding the capacitors, I measured all the capacitors in circuit, which the meter is capable of doing. The big ones all measure okay, so I'm not going to mess with those. In fact, most of them measure okay, so I'm not going to mess with them. I've decided I'm only going to replace, there's some 10 microfarad capacitors and some 15 microfarad capacitors, which look a little marginal. Their values in their ESRs. So the 15s are like these two right here, and the 10s are these blue ones. There, and there. And to replace them, what I got is, see, these are nice Sprague silver capacitors elsewhere, and then you've got these blue ones. Well, I found some Sprague silver ones that match the other Sprague capacitors in there, and these are new. Well, let's see. They're about 2 years old, sitting on the shelf, it looks like, from the date code. Which, of course, is weird. The 15s, which are already silver ones there, and these will just look absolutely identical, like nothing ever happened, unless you look at the date code. And these have, like, a 5-year-old date code on them. What's up with that? They've been sitting on the shelf for 5 years. But those are date from, like, 1979. So I think they have expired. It shouldn't hurt anything except potentially the calibration to replace these, and then it'll be you know, as good as new. Actually, I should measure these. Let me measure new ones. Let's do this. I want to give those 15 microfarad capacitors the best chance to stay. So I'm going to measure the new ones. And if they're not significantly better, then I will leave those other ones in place. Okay? Now I am measuring at a frequency of 120 hertz. And there's ESR. Okay. So here's number one of the new ones. So 18.8 microfarads, but an ESR of 4.7 ohms. 4.7. That's way better. ESR-wise. Okay, and here's capacitor number 2 of the new ones. 19.5 microfarads. So the old capacitors read closer to the actual nominal capacitance. But this one, the ESR is 4.5 ohms. And both of the old ones measure over 20 ohms ESR. So yeah, they're getting replaced. All right, and here we are. This is the finished mods. Got it all back together. As you can see here, I've moved the broken switch over to the far right, which is, I think, likely to be the least used switch in my case. These switches no longer wobble. The lights all work, as we can see. Hopefully you can see. The capacitors are replaced. I replaced this one and this one, the 15s. I might have, in a previous thing, I might have said I was replacing, that this was one of the 15s. It's not. That's a 5, so it's these two are the 15s. And then here, 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 and here. These used to be blue. Now, oh yeah, and then I've straightened out the covers so they fit. There's no more bulges when it fits together. Capacitors. Capacitors. The 10s. Out of circuit actually all measured okay. Oh well. And they look like, I don't see it. I mean, there's a date code on them, I guess, which says 015, it looks like. 015. Well, everything else in there is like 1979 date codes. 015 could be 1980, 1990, 2000, 2010, 2020. Who knows? Probably not 2020. But it's possible. Well, no, I was going to say those might have been replaced at some point, but then I would have expected to see some, damage to the conformal coating underneath. I don't know. The 15s, on the other hand, measured actually worse out of circuit than in circuit, so they really did need to be changed. And in fact, if I measure these with a measure the ESR at, well, and capacitance at a frequency of 1 kilohertz, which is sort of more standard. I was using 120, which is great for power supplies. But I don't think these 15s are in a power supply circuit. I don't remember where they're at. So now we're at 1 kilohertz, which is the default here. This is supposed to be 15 microfarads. And, okay, so it's reading 5.8, well, 5.7, 5.6. Anyway, well under 15. And 14 ohms ESR. If I change that frequency back to, let me put it at 120, which is what I was using before, you can see it measures 18 microfarads, which is what I was seeing in circuit, and 27 ohms ESR. So, yeah, that one's garbage. This one, I think we'll see something similar. Let it stabilize. Anyway, we can see pretty high capacitance. This is I forget if this is minus 10 plus 50, or there's some that were minus 10 plus 75 tolerance. Any case, the ESR is quite high, and if I change the frequency to 1 kilohertz, we'll see again here that I get 6 point whatever microfarads, and still, you know, close to 12 ohms ESR. So, yeah, so those were bad. Taking a look at one of the 10 microfarads, and I'm only going to do one because they all tested good, but you'll see, you'll get an idea. So I didn't actually have to replace these. There you go, 11 microfarads and 3.6 ohms ESR. That's at 1,000 at 1 kilohertz. If I put it to 120 hertz, 13 and 7.7. Still not bad. Yeah, so like I said, I could have kept those. So now I guess the question is, how accurate is it? Did replacing those capacitors affect the calibration? Actually, looking at the circuit, which I did once, those really shouldn't affect, those that I replaced shouldn't really affect the calibration. And it does seem to be pretty much spot on still. This has been operating for a while. So I've got it at set to 10 volts output, 10.00000. And on the Tektronix, we've got 10.0001, which is you know, off by one count. It's well within spec for this thing, or the combined thing is well within spec. The place where it may not be in spec, if I go down to, well, again, zero, I think it wants to see something like 20 microamps. And we're seeing about 40. Okay, minus 40. If I turn this around, you know, maybe there's some offset built into the meter. I don't know. I'll short the leads together. About 6 of that is just built in to the meter. If I turn this around, so I'm showing 28 microvolts ish. Versus 42, 43, so, or minus 43. So definitely, because I swapped the leads, the sign will change. So definitely there's something, this is not at zero output. But, so that's something maybe of concern. The other thing is on the low millivolt range. So this is 190 millivolts, and now when it was calibrated, 190 got a reading of 190.002 as found. Anything 189.964 to 190.037 would be in spec. We're seeing 189.937, so that's out of spec. But we believe that the meter is in spec, so that would say this guy is out of spec down at those sort of lower levels. And if we go to the high voltages, let's say go to 1,000. This is 1,000 volt range. Again, reading 0, 58 microvolts. I don't know if that's in spec or not. 1,000 volts out of this. Pretty close. Pretty close. Let's see. When it was calibrated, it was 1000.010 as found. In range is 999.82 to 1000.18. You know, this is off by 3 counts, which is well within spec for this thing. Right? I'll have to figure out what to do with this if I want to try to get it better in calibration, because it seems slightly off.